I'm a chemist, as I mentioned, and what that means is that I work with chemical reactions. That's what it means to be a chemist. We study chemical reactions. And so a chemical reaction involves a compound, one or many, changing into another one. Through chemistry, you're changing the chemical makeup of that compound. And so you take one material, one substance, one sample, change it into another. Anytime that happens, that's called a chemical reaction. If that doesn't happen, it's not a chemical reaction. There might be something that changed, but if the actual sample didn't change, it won't be chemistry, it won't be a chemical reaction. So almost everything we're going to do today is a chemical reaction. There's one demonstration we're going to look at that will not be. We'll talk about that when we get to it. And so yeah, we're going to play around with some chemistry. Hopefully you'll find it entertaining. And again, happy Halloween. And so we're going to look at, since we're studying chemistry, some different signs, telltale signs that a chemical reaction has occurred. And so the first demonstration we have involves this flask of clear liquid. So, I want you to take a good look. This just looks like water, right? It looks like water. It's just clear liquid. No telltale thing in there. No hidden object like magicians talk about. Nothing over here. Nothing over there. Just clear liquid. And so, give it a couple shakes, and you get this beautiful, dark, bright blue color, like so. And just going to hang that over here for a minute, hang around with it, and talk about what's going on. And as I'm talking, you'll see that the color change is going to go away. And so this involves a chemical reaction. And in fact, this one is rather unusual up here because it goes back and forth. So the first two do that. And so you can see again that the color is fading. It's getting back to close to the color of just clear water again, no more blue. Shake it up. And go back. And I can do this as much as I like for quite a long time, on the order of hours. You can continue to do this. Color comes and goes. And so what's going on? You can tell that the liquid is not what's causing, the only thing causing the color change to happen. It's clear, looks just like water when I leave it alone. And so the liquid has some chemicals in there, but they're clear on their own. When I shake it up, what am I doing? I'm mixing the liquid with the gas above here, the air. We tend not to think about the fact that when you have something filled with liquid, partially filled, the rest is actually full. It's just full of air. And so in this case, the air is mixing into the liquid. And when that happens, there's a chemical reaction that occurs that generates this blue colored molecule. And then as I wait, the air likes to leave the liquid. It would rather be in the gas again. Right? That's where it would prefer to be. That's where it typically is in the gas phase. So it'll leave, and you'll lose that color because of that. And so every time I shake it up, I'm reintroducing more air. It's actually the oxygen in the air in this particular case that matters, into this and getting this beautiful color back. And then I let it sit, and the color goes away.